In this video lesson, we're looking at another way to calculate changes in energy called standard enthalpy of formation, which has the symbol, this is the symbol, delta H, subscript F, and then the little 0, that's superscript. So our standard enthalpy of formation is the quantity of energy associated with the formation of 1 mole of a substance. And it's its formation basically from its elements. So basically it's the amount of energy that's associated with making 1 mole of a substance from its elements. And it has to be from their standard state. So the state that the element is found in at standard temperature and atmospheric pressure. So a couple of things to note here is the first one is that the standard enthalpies of formation are known values, which means we know them. And if you look on page 798 in your textbook, you will see a very large chart showing the standard enthalpy of formation for many different substances. The second thing to note is that the standard enthalpy of formation of any element in its standard state is 0. So if you have an element that you're working with, you know you can automatically make it a 0. So our standard enthalpy of formation provides a new and easier way to determine enthalpy changes. This is because the enthalpy change for an equation equals the sum of the standard enthalpy of formation of the products minus the standard enthalpy of formation of the reactants. Mathematically, it looks like this. Enthalpy change equals the sum, so remember this sigma means sum, of the number of moles times standard enthalpy of formation of the products minus the sum, number of moles times the standard enthalpy of formation of the reactants. In case you might just want to label sum as sigma and this N is number of moles. Okay, so the best way to learn this is to do an example. So we're going to look at the combustion of propane, which is C3H8. And we know that for combustion to happen, our other reactants, oxygen gas, and we end up with products of carbon dioxide and water. A quick look at this tells us we do not have a balanced equation. So go ahead, pause this video, and balance. So if you've balanced this correctly, your coefficients are 5 O2 and 3 carbon dioxide and 4 waters. So just like any other problem, the first thing we want to do is write out our equation. So there's our equation. We know that our standard enthalpy or our enthalpy change is going to be sum of standard enthalpy of formation of the products times the number of moles, subtract the sum, the number of moles times the standard enthalpy of formation of reactants. Now you need to plug in your numbers. When you do this, use a really large square bracket. So essentially, you're going to put a square bracket around all of your data for your products and all your data for your reactants. You don't need to place your brackets here in your formula. I'm just showing you where they need to go. So down here on our next line, we are going to put the standard enthalpy of formation of our products, which happens to be carbon dioxide and water. But because we have to times it by number of moles, we have 3 moles of carbon dioxide, we know we're going to start with 3 times the standard enthalpy of formation of CO2, and then we add that to 4 times the standard enthalpy of formation, which we should have our zeros here, of water. And those are our 2 products. We put a square bracket, and then we can subtract another square bracket where we put the information for our products, or for our reactants, sorry. So now we have up here, we have an invisible 1. So we can even write that in. Maybe in blue. Invisible 1 here. So that means that we are going to have 1 times our standard enthalpy of formation of our propane, C3H8, plus 5 times the standard enthalpy of formation of O2 here, and a large bracket here. So now you have to sub in some more information. You need to visit that page in your textbook, 798, and find your given values for your standard enthalpy of formation of carbon dioxide, water, propane, and oxygen, and then you plug it in. These coefficients really mean number of moles. So our standard enthalpy of formation is going to equal square bracket 3 moles, small bracket, and looking at the chart, your given value is negative 393, and your unit is kilojoule per mole. Now we add our water information. So plus 4 mole times standard enthalpy of formation of our water, which happens to be negative 241 kilojoules per mole, small bracket, and that's the end of your product. So a nice big blue bracket around those, and then we subtract and start our information for our reactants. We don't really need to write this one. I just put it in here to show you that this invisible 1 really goes here. So actually, you know what? I'm going to change my mind. You should write that 1. So we have 1 mole times standard enthalpy of formation of propane is negative 104.7 kilojoules per mole, and then plus, I'm running out of space here, so I'm going to squeeze it in on the next line. I'm going to write it down here, plus 5 moles for oxygen. And remember that oxygen is an element in its standard state. Oxygen is found as oxygen gas. So that means it's really 5 moles times 0. So then what you need to do is just do the math inside the big blue bracket separately. So in your first big blue bracket, you solve all of this, 3 mole times negative 393 plus 4 mole times negative 241 kilojoules per mole. You get negative 2,147.7 kilojoules. And if you look up here, you're wondering why my unit is kilojoules. You just have to take a look and see that you have a mole here and a mole here that cancels out, and you're left with kilojoules. You have a mole here and a mole here that cancels out, and you're left with kilojoules. You do the same thing for your other big blue bracket. This one's really easy because it's 1 times negative 104.7 plus 5 times 0. So it equals negative 104.7. If you punch all of this into your calculator, you get negative 2,043.3 kilojoules. If you don't want to punch that all into your calculator, you want to simplify it up again a little bit, you can just remember using your algebra that a negative times a negative equals a positive. So really, negative 2,147.7 plus 104.7 kilojoules. We get our answer here. And then we want to finish with a nice therefore statement that the change in enthalpy is negative 2043.3 kilojoules. Okay, so make sure you have this copied down. You might want to take a minute and highlight where you see some color coding, just so you can follow it a little bit easier when you do some practice. And now we're going to do another example. So in our second example, we want to know what the enthalpy of formation of benzene is if the enthalpy of combustion of benzene, which is C6H6, to carbon dioxide and water is negative 3,273 kilojoules per mole. So the very first thing we need to do is create a balanced chemical equation. So if we write out the combustion equation for benzene, it looks like this. Benzene plus O2 reacts to produce carbon dioxide and water. A quick look tells us that it's not balanced. So if you start balancing, you start with carbon and you realize that you have 6 carbons over here on the reactant side. So you need to have 6 carbons on the product side. So you put in a 6. And then you look and you have 6 carbons over here on the hydrogen side. So you need to have 6 on the product side, which is easy enough again because you have H2, so you just need a 3 here. Now you look at oxygen. Looking at oxygen, you have 6 times 2 is 12, and 3 times 1 is 3. So 12 plus 3, you have 15. The problem is that it's impossible to make 15 oxygens over here because you have it as O2. 15 cannot be divided by 2. So what we do is a little trick. Because we are looking at enthalpy of formation, we want to balance our equation so we have 1 mole of benzene, which means we do not want to have to multiply our 6, or our 3 to bigger numbers, because then we would have to multiply here and we would have to have a coefficient in front of our benzene. We do not want a coefficient in front of our benzene. So instead, because we have 15 oxygens over here, what we're going to do is we're going to put a 15 in front of the oxygen, but then we're going to divide it by 2. So what we have is 15 divided by 2 times 2. And if you punch it into your calculator, you get 15. So make yourself a little note saying that we need to balance to have 1 mole of benzene. So that's basically our first step, is to balance our equation to give us 1 mole of benzene. The next step is, again, write out our formula. So our formula, same as before, total change in enthalpy equals our sum of number of moles times standard enthalpy of formation of products, subtract the sum of number of moles standard enthalpy of formation of reactants. This time we have the standard enthalpy, we have the change in enthalpy. So we know our change in enthalpy is negative 3,273 kilojoules per mole. So what we really need to do is rearrange our equation so that we have our standard enthalpy of formation of benzene. So what that means what you need to do is you need to take this and you need to break it apart into all of its components up here. So if we break it apart, it looks like this, just the same as in our other example. We have our number of moles are coming from our coefficients, and we just put in the symbol for standard enthalpy of formation. So I would always include this step here. It's really hard, and there's a lot of room to make mistakes if you go directly from this line to the next line where we sub in our values. I would also clean up as much as you can before you start rearranging. It actually is a lot easier to solve some of these big blue brackets before you start rearranging. And so that's what you should do next. Take this line, and your next line should be inputting your standard enthalpy of formations from your chart in the back of your textbook. So if you input your data from your tables, you get something that looks like this. Just a slight edit for you. This over here where this 3 moles, it should be 15/2. So that's a mistake that I made. So you plug it all in, you have this big long equation. Now solve as much of those blue brackets as you can. You also can input over here the fact that you have your enthalpy change is negative 3,273 kilojoules. And that equals, now, if you do all the math in your blue brackets. So you do your first bracket and you end up with negative 3,217.5 kilojoules. Remember, your units cancel out nicely because you have mole here and mole here, mole here and mole here, and you're only left with kilojoules, which means you have to have units kilojoules here. Your second blue bracket simplifies a lot easier because you have 15/2 times 0. So really, all of this equals 0. And then you're left with 1 mole times standard enthalpy of formation of benzene. So now 1 mole, really, we don't need to include that. It's just a 1. We have to recognize it's there though, so when our units cancel out, we're left with kilojoules. I'm going to show you what would happen if you left your moles in place. And that way, if you ever have a balanced chemical equation where it's not a coefficient of 1 here, you know how to solve it. So we can simplify our second blue bracket. And basically, we're just left with 1 mole times standard enthalpy of formation of benzene. And that's pretty easy, so we don't even really need a bracket. We can just say we're going to have 1 mole times our standard enthalpy of formation of benzene. Now we have to rearrange. In order to get rid of this negative 3,217, we are just going to add it to both sides. Our other option, though, is a little bit better. What we can do is we can take this number and move it over here by making it positive, and this part and move it over here on this side of the equal sign, making it positive. So if we do that, what we really end up with is something that looks like this. We have our 1 mole of benzene times standard enthalpy of formation of benzene equals the negative 217.5, which was here already, plus the 3,273 kilojoules. So now simplify this side, do your math. So you do the math and you get 1 mole times standard enthalpy of formation of benzene is 56 kilojoules. But we're not done, because what we have to do is get standard enthalpy of formation of benzene by itself. So we have to go 56 kilojoules divided by that 1 mole. And we do that, 56 divided by 1 is 56, but our unit becomes kilojoule per mole. If you balance your equation so that you do not have a coefficient of 1 for our benzene, you would just carry whatever that mole is through this whole process, and instead of dividing it by 1, you would divide it by whatever the coefficient was in front of the benzene. So that is the whole solution on how to calculate and rearrange using standard enthalpies of formation. Of course, for perfect communication, you would finish off this example with a wonderful therefore statement. Okay, so that's the end of this lesson. Go ahead and make sure you have it all copied down in your notes. I would really strongly encourage you to color code using some highlighters like you've seen here. And the best way to really learn how to do this is to do some practice. So thank you, and I will see you in class.